The angle of elevation of an object Q from an observer who is at P is the angle which the line PQ makes with the horizontal. So angle of elevation is always an observer who is below a certain level trying to look up to an elevated surface. Here this observer who is below Q is trying to look at the point Q. The angle with which PQ mixed with the horizontal becomes the angle of elevation, like this. Now, how do you find the angle of elevation? This now here becomes a right angle triangle. You realize that this side here is opposite to the angle theta, and here is adjacent to the angle theta. So from the simple diagram here illustrating angle of elevation from SOHCAHTOA in the previous video, tan theta is equal to opposite, which is A, over the adjacent, which is now B. We can find theta as T is equal to tan inverse of A over B. Theta becomes the angle of elevation. Here, it is assumed that the height of this observer is irrelevant to the height of the elevated surface. In some question, the height of the elevated surface will be on the same level ground as the observer. And then in that case, in calculating for our angle of elevation, we will look at the eye level of that observer. The eye level, our horizontal will be the eye level of the observer. The angle which the eye level makes with PQ will be the angle of elevation. Let's look at some examples in angle of elevation. Our first example says, from a point 60 meters from the foot of a vertical pole along a level ground, the angle of elevation at the top of the pole is 42 degrees. What is the length of the pole? Remember, in the previous videos, I said that to be able to solve questions like this in trigonometry, you must first be able to represent the information in a diagram form. So here, let's go ahead to represent the information in a diagram. From a point 60 meters from the foot of a vertical pole, I'll first draw the vertical pole like this. Here becomes the vertical pole. And then from a point 60 meters from the foot, this is the foot of the vertical pole. And from this point, which is 60 meters from the foot of the vertical pole, which is 60 meters from the foot of the vertical pole, the angle of elevation at the top of the pole, here is the top of the pole, and from this point, the angle of elevation, meaning we are from here and we are observing here. The angle of elevation of the top of the pole is 42 degrees. So my here will be 42 degrees, like that. What is the length of the pole? Let the length of the pole be h. So here we are supposed to find this side, the dimension of the pole, the length of the pole. Now here forms a right angle triangle. And we've learned in the previous video how to relate the trigonometric ratios to the size of a right angle triangle. So remember, from SOHCAHTOA, the appropriate trigonometric ratio which relates the opposite, which is the height of the pole, to the 60 meters here, which is adjacent to the angle 42, is tan. You realize that even the angle of elevation, the appropriate trigonometric ratio used here is tan of the angle theta to find the opposite and the adjacent side. So from here, tan of the angle 42 is equal to, tan is opposite over adjacent. Here is opposite to the angle 42. So it will be equal to h over the adjacent, which is now 60 centimeters. 60. Now to solve for h, we all know we will first cross multiply or make h the subject. And from here, our h is now 60 times tan 42 degrees. So h will now be equal to 54.02 meters. This is now the length of the pole, which is approximately, h is approximately 54 meters. This becomes the length of the pole. Let's quickly look at the second example. Our second example is calculate the angle of elevation measured from a point on the ground to a 50 meters tree, that is 20 meters away from the tree. Here we are to find the angle of elevation. To solve this, we must first represent the information on the diagram. We first have to draw our tree. So this becomes our tree. And the height of the tree has been given as 50 meters. Okay. And from a point which is 20 meters away from the tree. So from a point 20 meters away, here becomes 20 meters away from the tree. We should calculate the angle of elevation. We all know that from here, the angle of elevation is what? Looking above, looking at the top of the tree. So we are interested in this side. The angle here is what we are looking for. This becomes our angle of elevation. So let's look at it. From SOHCAHTOA, from the same SOHCAHTOA, the appropriate trigonometric ratio is still tan. To find the angle, tan of the angle theta is equal to opposite. Opposite is 50 over the adjacent, which is now 20. How do you solve for theta? If you've watched the previous video, this should be very simple for you. Theta will now be equal to tan inverse of 50 over 20. From the calculator, so the value of theta here is 68.2 degrees. This becomes the angle of elevation for looking at the top of the tree. Very simple. Now let's look at angle of depression. Angle of depression. Angle of depression. When we have an observer who is above a certain level, trying to look downwards, the angle with which line AB mixed with the horizontal becomes the angle of depression. Beta here becomes the angle of depression. The angle with which the line mixed with the horizontal, please take note, not the vertical, but rather the horizontal, becomes the angle of depression. Now watch something here. We all know that from plane geometry, alternate angles are equal. Alternate angles are equal. Therefore, the angle here will be the same as the angle here when it comes to angle of depression, since alternate angles are equal. Now, how do we find the value of the angle beta, which is the angle of depression? From SOHCAHTOA, or just like we did for elevation, the appropriate ratio will be tan. Tan of the angle beta will be equal to opposite. Now the opposite is what? The side D over the adjacent, which is now the side C. And from here, beta will be equal to the tan inverse of D over C. Let's quickly look at our first example and the angle of depression. First example, a lighthouse tower is 35 meters above sea level. If the angle of depression of a boat from the top of the tower is 15 degrees, how far is the boat from the lighthouse? To be able to solve this, we first have to represent it in a diagram. So I'll first draw my lighthouse tower. This will be the lighthouse tower. and is 35 meters above sea level. Above sea level, 35 meters. Assuming here is the sea level, then it's 35 meters above the sea level. If the angle of depression of a boat from the top of the tower, angle of depression from the top of the tower to a boat, assuming here is a boat, this is our boat here, there's a boat on the sea at this point, then the angle of depression from the top of the tower to this boat, to the boat, is 15 degrees. Now remember, angle of depression is always to the horizontal, not the vertical. So the angle of depression will be here, 15 degrees.
The angle of depression is always to the horizontal, not the vertical. And remember, we said alternate angles are equal. So here will also be 15 degrees, like this, because alternate angles are equal. Now, we are asked to find how far is the boat from the lighthouse. Here is the foot of the lighthouse and here is the boat. So we are looking for this distance. Let's represent the distance by a variable x. Now, to find the distance x from SOHCAHTOA, the appropriate trigonometric ratio that relates 35, which is the opposite, to x, which is the adjacent, will be tan. So therefore, tan of the angle 15 degrees, tan 15 degrees is equal to opposite, which is 35 meters, over the adjacent, which is x. How do we solve for x? From here, we cross multiply again, and then we have, after multiplying, we have x times tan 15 is equal to 35. We divide both sides by the coefficient of x, which is tan 15. So here over tan 15 and then 35 over tan 15. Tan 15 will cancel tan 15 and x is equal to 35 over tan 15 degrees. From the calculator, 35 over tan 15 will give you a value of 130.6 meters. So x is equal to 130.6 meters. The boat is 130.6 meters from the lighthouse. In the next video, we'll look at practical application questions under angle of elevation and angle of depression. Subscribe so you don't miss it. Thank you.